Hello friends. So in this video we are going to see the psychrometric chart. Basically how to read the psychrometric chart, how to plot the point on the psychrometric chart. But before proceeding to the psychrometric chart, first understand what exactly the meaning of psychrometry. Basically the psychrometry is the branch of science, it's a branch of science which deals with which deals with the properties of moist air. Okay, so basically the psychrometry is the study of moist air. Okay, it is the study of moist air. Fine, and that study we are going to do with the help of psychrometric chart over here. Fine, so here in this case you can see this chart is nothing but the psychrometric chart. Okay, so your name is given psychrometric chart, and this chart is drawn at atmospheric pressure 1.013 bar. This is very important to see at what pressure this chart has been drawn. Fine. Now in this chart I'll just tell you what are the various lines. So this particular curve which you are going to see over here, okay, this is the last curve. This curve is known to be the saturation curve. This curve is known to be the saturation curve. Okay, so I am writing down over here, this is the saturation curve. Then the on the x-axis you can see the temperatures -5, 0, 5, 10 and likewise. So these are nothing but the dry bulb temperature lines. These are nothing but the dry bulb temperature line. So the line which are running vertical over here, the lines which are running vertically over here, these are the dry bulb temperature line. Okay, these are nothing but the DBT lines. Then the line which are going to see over here, the slant one over here, these lines, okay, these lines, these are nothing but the wet bulb temperature lines. Okay, these are nothing but the wet bulb temperature, and that wet bulb temperature you can see over here 5 degree, then 10 degree, 15, likewise. Okay, these are nothing but the wet bulb temperature line. Then the line which are going to run in a curve over here. Okay, so these curves are nothing but, these curves you can see are nothing but the relative humidity lines, RH lines, the relative humidity lines. And the relative humidity mostly, or rather always, it is expressed in terms of percentage. Fine, so here it is 40%, 45%, 50%, 55%, likewise these curves are there. So when I observe the saturation curve, this is the curve, at this saturation curve the relative humidity is 100%. Relative humidity is 100%. Fine, then if I extend this particular saturation, wet bulb temperature line beyond the saturation curve, okay, then you can see there is one scale provided over here. Okay, so this particular scale, this is the scale. So this scale is nothing but the enthalpy scale. Okay, it is given over here. It's an enthalpy scale. So if I extend this wet bulb temperature line, wherever this particular line intersects to this particular enthalpy scale, I'll get the enthalpy at that particular point. Fine. Then on the y-axis on the right hand side you can see the numbers are written as 0.015, 0.020. Okay, likewise it's a 0.018 basically. Fine, so this is nothing but the specific humidity scale. This is nothing but the specific humidity scale. So the horizontal line which are running over here towards right are nothing but the specific humidity lines. And these lines, this horizontal line, if I extend towards left, let's say over here, okay, and wherever it is cutting to the saturation curve, let's say this is the line which is cutting to the saturation curve at this particular point, then this particular line is known as the dew point temperature line. Okay, dew point temperature line. So this is specific humidity line, W line. These are which are running towards left are nothing but the dew point temperature line, and the point which is cutting over at the saturation curve will give you the dew point of that particular point. We'll see how to get those points. Then you can see one scale over here. Okay, this particular scale, Okay, this particular scale which you can see over here, this is nothing but the sensible heat factor scale, SHF scale. This is the SHF scale. This scale is very important to go for the numericals based on the cooling load estimation or the air conditioning. Okay, then the line which are running slant over here, you can see at some gap you are going to see these lines. These lines are nothing but the specific volume lines. These are nothing but the specific volume line. Now you can see it's a zero point 0.9 meter cube per kg of dry air. So this is the specific volume line of 0.9 kg per meter cube of dry air. Sorry, meter cube per kg of dry air. Then this is 0.88 meter cube per kg of dry air. This is 0.86, 0.84 and likewise. Okay. So these are the specific uh, volume lines over here. These are also very much important to get the volume flow rate. Okay, so this is what the psychrometric chart is. Okay, so I'll just explain it again in short. This is the saturation curve. Vertical lines are the dry bulb temperature lines. The slant line over here is nothing but the WBT lines. Then the curves are nothing but the RH curve. Horizontal lines towards right is nothing but the specific humidity lines. The horizontal line towards left are nothing but the dew point temperature lines. This is the specific humidity scale. This is the sensible heat factor scale. This is the enthalpy scale over here. Okay. So this is what the psychrometric chart is. Fine. Now we will see how to get the properties of any point on the psychrometric chart. For example, suppose the condition for air is given as let's say 35 degrees Celsius dBT and let's say 55% RH. Okay, this is what the point given. So with respect to this particular point, what are the various properties that we will see, how to get those. So I need to get the point of this particular condition, 35 dBT and 55% RH. So I look for dBT. So these are the dBT line 30, 35, fine. So the line which is running vertically over here, so this is the 35 dBT line. This is the 35 dBT line basically. Okay, fine, 35 dBT line. And wherever this particular 35 dBT line intersects to the 55% RH, so this is the 50% RH, this is the 55% RH. So wherever this 35 dBT line is intersecting to 55% RH, I will get that particular point over here. I will get that particular point over here. So this is that particular point. With respect to this particular point, now I will go for getting the various values. So dBT is 35 dBT, RH is 55%. Then with respect to this particular point, the WBT, if I want to find, the WBT will be, let's say this is what the line for WBT. So here it is 25, 26, this is 27 and bit upward to the 27. So it is around 27.1 degree Celsius is the WBT. Then with respect to this, if I want to have the dew point temperature, so I will go horizontally over here. Wherever it is intersecting to this particular saturation curve, I will get the dew point temperature. So this is between 24 and 25, almost about 24.5 degrees Celsius. So dew point temperature is to 24.5 degree Celsius. Then if I want to have the specific humidity at this particular point, I'll go towards right over here. Okay, so this is 0.018, 0.02, so this will be something like 0.0195 about. Okay, so this is the W value, let's say 0.0195, something like that. Okay, so that is what the W value. Obviously the unit you can write this for specific humidity of the W is kg per kg of dry air. Then if I want to have the enthalpy, what I will do, I will mark a parallel line to this particular WBT line over here from this point. From this point I will mark a parallel line over here. So if I extend this particular line, let's say something like this, this is the parallel line I have to mark obviously. Okay, something like this. Wherever it is intersecting this particular scale, enthalpy scale, that is the enthalpy at this particular point. So enthalpy is about 85, 86. So enthalpy H is equal to 86 kilojoule per kg of dry air. Okay, this is what the how we can gauge the various conditions or the properties with respect to that particular point. Okay, so this is what the psychrometric chart. Thank you.